For centuries, humanity has sought to understand the fundamental nature of reality. From ancient philosophers to classical physicists, our models of the universe have largely been built upon predictable, observable phenomena. We believed in a world where cause precedes effect, and objects possess definite properties independent of observation. Then came the quantum realm, a domain where these bedrock assumptions crumble. It introduced a universe far stranger and more counterintuitive than anyone could have imagined. Here, particles can exist in multiple states simultaneously, and their very nature seems to shift based on whether or not we choose to look. This quantum strangeness is not merely theoretical, it is repeatedly confirmed by experiments. These experiments challenge our deepest intuitions about existence, causality, and the role of consciousness itself. They force us to confront a reality that defies our everyday experience. Among these mind-bending investigations, one experiment stands out for its profound implications and enduring mystery: the delayed choice quantum eraser. It pushes the boundaries of what we thought possible, suggesting that the past itself might not be as fixed as we assume. To truly grasp the enigma of the delayed choice quantum eraser, we must first revisit its conceptual ancestor, the double-slit experiment. This foundational quantum demonstration reveals the bizarre duality of light and matter. It shows that particles can behave as both waves and particles. When individual photons or electrons are fired at a barrier with two slits, they create an interference pattern on a screen behind it. This pattern is characteristic of waves, suggesting each particle somehow passed through both slits simultaneously, interfering with itself. However, if we attempt to observe which slit a particle passes through, the interference pattern vanishes. The particles suddenly behave like discrete bullets, choosing one path or the other. The act of observation collapses their wave-like nature into a definite particle state. This observer effect is not about consciousness in the human sense. It refers to any interaction that extracts information about the particle's path. The mere potential for information acquisition fundamentally alters the particle's behavior. The double-slit experiment presents a profound paradox. How can a particle know whether it is being observed and adjust its behavior accordingly? It seems to defy our classical understanding of objective reality. The delayed choice quantum eraser builds upon this paradox by incorporating another cornerstone of quantum mechanics: entanglement. Entanglement is often described as spooky action at a distance, a term coined by Albert Einstein. When two particles become entangled, they become inextricably linked, sharing a common fate. Measuring a property of one entangled particle instantaneously influences the corresponding property of the other, regardless of the distance separating them. This connection seems to transcend space and time. Imagine two coins, one in New York and one in London, that are entangled. If you flip the New York coin and it lands heads, you instantly know the London coin will land tails, even before anyone looks at it. Their states are correlated in a way that classical physics cannot explain. This instantaneous correlation is what troubled Einstein, as it seemed to violate the cosmic speed limit of light. Yet numerous experiments have confirmed the reality of entanglement, making it a fundamental aspect of the quantum world. The delayed choice quantum eraser leverages this entangled relationship to explore the double-slit paradox in an even more perplexing manner. It introduces a twist that challenges our understanding of cause and effect. The delayed choice quantum eraser experiment typically begins with a special crystal. This crystal uses a process called spontaneous parametric down conversion to generate pairs of entangled photons. These photons are born simultaneously, sharing an intimate quantum connection. One photon from each pair, often called the signal photon, is directed towards a double-slit apparatus. This is the photon whose wave-particle duality we intend to investigate. It will either create an interference pattern or a witch path pattern. The other photon from the pair, the idler photon, takes a different path. Its journey is crucial for the eraser aspect of the experiment. It carries information, or the potential for information, about its entangled partner. The key innovation lies in the experimental setup for the idler photon. Its path is designed to allow for a delayed choice in how we interact with it. This delay is what makes the experiment so profoundly mysterious. The signal photon hits the screen and registers its position, seemingly before any definitive measurement is made on its entangled idler partner. This temporal separation is central to the experiment's perplexing results. After the signal photon has already passed through the double slit and hit the detector screen, a crucial decision is made regarding its entangled idler partner. This decision is the delayed choice. The idler photon can be directed in one of two ways. In one scenario, its path is manipulated to reveal which path information about its entangled signal photon. This means we can determine which slit the signal photon passed through. In the other scenario, the idler photon's path is manipulated to erase any potential which path information. This is achieved by mixing the idler photons in a way that makes it impossible to deduce which slit their signal partners took. Crucially, this choice is made after the signal photon has already interacted with the double slit and registered its position on the screen. The signal photon has already chosen whether to behave as a wave or a particle. This temporal separation creates a profound puzzle. How can a measurement made on the idler photon after the signal photon has landed seemingly influence the signal photon's past behavior? It appears to defy the conventional flow of time. When the idler photon's path is set up to reveal which path information, the corresponding signal photons, when analyzed, show no interference pattern. They behave like particles, just as in the original double-slit experiment when observed. This is expected. However, when the idler photon's path is set up to erase the which path information, something truly astonishing occurs. The corresponding signal photons, despite having already hit the screen, suddenly exhibit an interference pattern. They behave like waves. This means that by erasing information about the idler photon after its entangled partner has already passed through the slits, we retroactively restore the wave-like behavior of the signal photon. It's as if the signal photon waited for the future decision of its entangled partner. The experiment suggests that the choice of whether a photon behaves as a wave or a particle is not made at the slits. Instead, it seems to be determined by a future measurement, or lack thereof, on its entangled partner. This outcome challenges our fundamental understanding of causality. It implies that future events can influence past events, or at least our knowledge of them, in a way that is deeply unsettling to our classical intuition. The delayed choice quantum eraser experiment has profound implications for our understanding of reality. It suggests that the past is not necessarily fixed and immutable, but rather can be influenced by future observations. One interpretation is that the choice of wave or particle behavior is not made until all potential information about the particle's path is either gathered or irrevocably lost. The universe seems to delay its decision until the last possible moment. Another perspective suggests that the experiment highlights the non-local nature of quantum reality. The entangled particles are not separate entities, but rather parts of a single, interconnected quantum system. Their fates are intertwined across space and time. Some physicists propose that the experiment demonstrates the limits of our classical language in describing quantum phenomena. Our concepts of past and future may not apply in the same way at the quantum level. The experiment does not allow for sending information back in time, thus preserving causality in a practical sense. However, it forces us to reconsider what information truly means in the quantum realm and how it shapes reality. Despite numerous confirmations and variations, the delayed choice quantum eraser remains one of the most mysterious experiments ever conducted. It continues to provoke intense debate and philosophical inquiry among scientists and thinkers. It challenges our deepest assumptions about the nature of time, causality, and objective reality. It suggests that the universe is far more interconnected and responsive than our everyday experience leads us to believe. The experiment serves as a powerful reminder that our understanding of the cosmos is still in its infancy. The quantum realm continues to hold secrets that defy our intuition and push the boundaries of human comprehension. As we delve deeper into these quantum enigmas, we are forced to confront the possibility that reality itself is not a fixed stage upon which events unfold, but rather a dynamic, participatory process. The universe, in its deepest essence, remains a profound mystery. The delayed choice quantum eraser is not just an experiment. It is a window into the fundamental strangeness of existence. It invites us to question everything we thought we knew and embrace the wonder of the unknown.